This video will show you how to solve certain types of exponential equations. These equations are going to have bases that are going to equate on both sides of the equal sign. So the directions will say solve each exponential equation by expressing each side as a power of the same base, and then we're going to be able to equate the exponents. This should be pretty obvious that 3 to the x can be solved equal to 81 because 81 can be written as 3 to the fourth. Now, how do I know that 81 is 3 to the fourth? Well, I just happen to know that 81 is 3 to the fourth. How do you know it? Two ways. One is play with your calculator. Try 3 to the second. Nope, that doesn't work. Try 3 to the third. Nope, that doesn't work. Then go to 3 to the fourth. Yep, there's 81. As soon as you have an expression like this where the bases are equal, that means we're allowed to set these two exponents equal to each other, and we just get x equals 4. Because 3 to the fourth gives us 81. Now that's a very basic, easy example. If you don't have a calculator or don't want to use a calculator to come up with what this power is, then here's another choice. New problem, 5 to the x equals 625. If you don't know what power goes on 5 to make 625, you can do this method called successive divisions. We're going to keep dividing by 5 because that's the base we have over here. And you keep dividing 5 and it comes out evenly down here as a 1. That tells you that this 625 can be written as a power of 5. And it's written as a power of 5 to the 1, 2, 3, 4. So this is 5 to the fourth equals this 5 to the x over here. So obviously, if the two expressions are equal and the two bases are equal, we can set the exponents equal, and there's our answer of x equals 4. This one looks like it might be a little more complicated because the exponent is a binomial, but it's the same process. You have to have the same base on both sides. So we have to come up with what power goes on 3 to make 27. You can do the successive division thing if you want. Just keep dividing by 3. 3 goes into 27 9 times, divide by 3 again, 3 goes into 9 3 times, 3 goes into 3 1. As long as you can get down here with a 1 and have the same number on the outside, then you know you can write this as a power of 3. If you don't want to do the successive division, you can play with your calculator, enter 3 squared, 3 to the third, etc. until you land on 27. So it is 3 to the third is 27. And as soon as you're here, this is pretty easy. If the two expressions are equal and the bases are equal, that says that we can just equate the exponents. And this is just a plain old simple equation to solve. Subtract 1 from both sides gives us 2x equals 2. Divide both sides by 2, and we get x equals 1. Same idea here. We've got to get the same base, and the base that will work is 5 because 5 to the third is 125. Our two expressions are equal, the bases are equal, set the exponents equal to each other, 3x minus 1 equals 3, and solve. Add 1 to both sides will give us 3x equals 4. Divide both sides by 3, and we will get x equals 4/3. Now with this one, you look at 4 to the x equals 32, and you can try on your calculator, and no matter what you try as a power on 4, it's not going to give you 32. 4 squared is 16, 4 to the third is 64, so this is not going to work to be a base of 4. So you have to think about what other base could possibly work. Since 4 can be written as 2 squared, that says 2 is probably the power. So try on your calculator with 2 to the whatever to come up with 32, and this is how it works out if you use the successive division. Keep dividing by the 2, and that keeps dividing out till we get 1, so we know we can use a base of 2. That's 5 2's, so 32 is the same as 2 to the fifth. 4 can be written as 2 squared, so this is what you have on the next step. 2 to the fifth is 32 because of all of this. You know that 2 squared is 4. I've put that in parentheses, all raised to the x power. Over here, you have to think about your exponent law, which is a power raised to a power. So this is going to be 2 to the 2x, because when you raise a power to a power, you multiply those exponents. This stays 2 to the fifth. Finally, we have this side equal to this side. The bases are equal, so we can just set the exponents equal to each other, and you have simply 2x equals 5 to divide by 2, and we get x equals 5/2. You can leave your answer as an improper fraction. You can change it to the decimal, whatever you or your teacher wants to have right there. 125 to the x equals 625, same problem. 125 to the 1 is 125. 125 squared is huge, so there's no way we can use a base of 125. But since these both end in 5, then 5 would be a good thought for your base. So 625 is 5 to the 4th. We saw that on a previous problem on this video. 5 cubed is 125. I've written it in parentheses, raised to the x power. Use your power rule here, which is going to give me 5 to the 3x equals 5 to the 4th. The expressions are equal, the bases are equal, so I can just equate my exponents, and I have 3x equals 4, divide both sides by 3, and we get x equals 4/3. Do not write this as a decimal because it's 1.3 repeating. Either write it as the improper fraction, or you can write it as the mixed fraction 1 1/3. There's a couple things you need to remember to do the next couple of problems. A to the negative x can be rewritten as the fraction 1 over a to the x. Remember, negative exponents create fractions. And this is the mth root of a to the n. That's a root expression. Can be rewritten in the rational exponent form as a to the n over m. The inside power goes to the top. The outside index goes to the bottom. First thing I notice here is that 125 can be written as 5 to the 3rd, so it's still 1 over 5 to the 3rd. Because I have this as a fraction, I know that that means it could have been written with a negative exponent. So 1 over 5 to the 3rd is the same as 5 to the negative 3. We have equal expressions, we have equal bases, so now we can set the exponents equal to each other. So 2 minus x equals negative 3. Simple equation to solve, subtract 2 from both sides, gives us negative x equals negative 5, which means positive x equals positive 5. This is using the other rule. This is written as a root. I need to write this as the rational fraction. So this is 1 over 3 to the 1/3. I kept the 1 over. The cube root of 3 is just 3 to the 1/3. But I need to get this with a common base. So I wrote 9 as 3 squared. This is going to have to be written as 3 to the negative 1/3. Using your power to the power rule, this becomes 3 to the 2x. Now I can equate the exponents and solve this. To solve this, I can divide both sides by 2. And when you do a fraction divided by 2, it's like divided by 2 over 1, is the same as multiplying by the reciprocal, which gives me negative 1/6. We can have a base of e. It doesn't matter what this base is as long as it's the same. This is 1 over something, so I can go back to the negative exponent. This stays, set these equal to each other, and I'm dealing now just with the exponents. Solve this by subtracting x from both sides. If you subtract x from both sides, you have 4 equals negative 3x, divide both sides by negative 3, so x equals negative 4/3.